All right, today, remember the syllabus has changed, so the test is not a week from today. When's the test? Monday, thank you. Today's review day, so you can ask any questions you want, or I can grab old tests and we can look at some of those problems. I really don't care. How would you like to proceed? Let me start with, do you have any questions, first of all? Anything that you're itching to get off your chest? 3-6. Uh-huh. That's the last of what's going to be on the test. All word problem. Yep. 3-4 and 3-6 were all word problems. I don't remember where the train problem was. In there, yes, the train problem is inside of 3-6. So anyways, do you want me just to grab an old test? We can look at those. All right, let's see how we go. I'll give you one I gave you last year. You want train problems? I can do train problems to your heart's content. You want to do train problems first? All right. Since you're the only one speaking, you get to go first. What was I going? Oh, Alex. Yes, they're in Alex. Minimize that guy. Where was I gonna go? Here. I don't even remember if we did a train problem, to be honest with you. So we'll see if we.
Sit there and break it down at the time, figure out how to do it.
All right, yeah, let's do some train problems. There's a freight train. Let's do that one. I'll keep a page number so you know it. Problem 92 from 3-6. All right, so let's do this. Let's take a look at this train problem. And then what I'll do is, I think what I'll do is I'll do this one and then give you a similar one and see if you can do it. I don't remember what kind of a problem was one of the tests, so. Let's see, a freight train passes the Naperville train station at 9 a.m. It's going 30. 10 minutes later, that's important. A passenger train headed in the same direction on an adjacent track passes the same location at 45 miles per hour. So when are they going to catch? When are they going to catch the other train? Since it's going 45 miles an hour, that one's only going 30. It will catch it eventually. So when do you think that would happen? Well, remember, this is a motion problem. So the key to these problems is the following equation. I almost never even have to tell people what those letters are. They usually don't. Distance equals rate times time. Any kind of a motion problem is going to involve this equation. So they want this at what time? So we're gonna call it T. That'll measure the distance. So if we look, the one train going 30 miles an hour. So the one guy is this. That's the first train. Let's call this the first train. And the second train, we have D equals 45 T minus 1/6. And I'll pause there.
Why do 1/6?
I'm glad you asked. Let's take a look at some of these numbers. 45 is evident. That's the speed, right? Why did I decrease his time by 1/6 of an hour? Why would I decrease his time by 1/6 of an hour?
Difference in speed.
So, reading it, how long, when did that guy start, the second guy?
Oh, because it took 10 minutes.
He started 10 minutes later. I didn't put -10 though, did I? Why? This 45 is in miles per what? I can't take out and mix it with minutes. So that has to be in hours. Now, notice that I used the same letter D for both of these equations. Is that true? Aren't we interested in the time when they get to the same point? I.e. they travel the same distance? That's what we want. So we can set these two equal to each other because this D is the same as this D. And so we get 30T equals 45 times T minus 1/6. The 1/6, that's the 10 minutes right there, but you have to change it to hours. How would you solve an equation like this? What would you do first? Word problem, everybody says the word problem is the hardest part is getting to the equation. The equation is usually easy.
Distribute the 45 into the.
Yeah, do that first. Remember, always simplify both sides of the equation. So I'll distribute the 45 through to both parts. Now, I don't know if you know this, but 3 goes into both 45 and 6 there. So I'm just going to make a slight change. You guys understand the 15/2? Did I explain that? All right, what would be the next step?
T on one side.
Get the T all by itself on one side, so since I've already, the number's over there, so I'm gonna subtract 45T. So what I get then, get my equals in here, on the left, I'm gonna get negative 15T. And on the right, I'll get negative 15/2. Almost done. What we should do now?
Divide both sides by negative.
Divide both sides by negative 15. It may look kind of funny over here, so instead of writing that, I'm gonna write -1/15. Which is the same thing. That way, this, and this all cancel. And what are you left with for the letter T?
Equals 1.
1/2. All right, so how long did it take for the second train to catch him? A half of an hour. Does that make sense? 1/2 of an hour. The guy that's going 45, half an hour, he would have gone 22.5 miles. Yeah, okay. I got the trains mixed up. The guy that was slower is the one that started earlier, 30-mile-per-hour guy. All right, so, in half an hour, the 30-mile-per-hour guy went, I'm trying to check myself, so let me do this. Okay, so in half an hour, the 30T train travels 30 times 1/2, which gives me 15 miles. Now, in the other guy, he didn't start till when? 10 minutes later? So he only got 20 minutes. So for the other guy, they were going 45 miles an hour, but they only got to do it for how long? 20 minutes, which is a third of an hour. Yeah, 1/3 of 20 minutes. Now, when I multiply it all out, I get 15. So I know that they travel the same distance. That is not required of anything. I was just checking. These problems are unusually easy, but at the same time, they seem kind of slippery. I'm not exactly sure what that story's about, but let me get you one that's just like it and see if you can handle it. We could literally spend all of class doing train problems if you wanted to. All right, let's grab another train one. This one, man, the odd ones are just like it. Let me grab number 91 and let you have at it. Slightly different question, but the idea is very similar. I'm not sure if I can get it all to come on one page, one thing. I can't do it. Actually, I can. You don't need to see the solution, you need to see the setup. Let's do that then. There, I've tried to get this one and the setup of the old one on the same screen for you. When you think you got it, let me know. I'll come around and show you my answer. Anybody got this in here? Let me. Perhaps give you some hints. Take that out of that spot. Sometimes it helps to make a picture. It just, at least it helped my thinking on this one. This is a strange problem.
Goes this way.
Intersection here. And this cargo van is going in this direction at 30 miles per hour. That's the van. The car, they're measuring it from the intersection, is going that speed, but we don't know how fast. Okay? Now, they say at 1 PM, that's important. How far is the van from the intersection at 1 PM? 1 PM, the van is 30 miles there. The car, how far did the car travel? Right? How long did it take to do that? So they said the car started at 12:30, right?
Yes.
So how long did the car drive for? 30 minutes, which is 1/2 hour. All right, so this car, we don't know what the rate was, but we do know for the car that the distance was 24, and that equals rate times time. If I want to get that little R, what do I got to do?
That's, divide the 1/2 by both sides.
Or I can multiply both sides by 2.
That's it.
Either one of those will do the trick. And we end up with 48 equals R. So the correct way to answer this is 48 miles per hour. Right, so how's your confidence with the word problems now?
So, but I think I understand.
Do we want to do more training problems, or do we just want to start the review? On its own? I really don't care. It's your time. I get paid the same whether we do that or this. So you want, I'll pull out an old test then. I'll grab the one from last year.
Question as far as the test.
Yeah, go ahead.
Is it going to be online or in class?
I'm sorry, I didn't hear what you said.
I said, is the test going to be online or
Oh, in class, in class. You gotta be here for it.
Okay.
Yeah, it's gonna be a written test. The Blackboard. All right, let's see, where would I have the old test? See this? Let's see if I had any from fall 2021. I got them in there, okay. I have solutions, okay. Oh, no, do I want to write? I don't know if I want to write it with the solutions there. Okay, I can probably cut these and put them in our thing. All right. I'll grab them in chunks like this then. So this is a test from fall. Hopefully the earlier stuff seems really easy compared to what we've been doing. But most of the test is not word problems. Most of the test is these computational things like this. Give those 4 a try. I'll do them too. And when you get them, let me know. I'll check your work versus mine. When you think you got them, call me over. I'll be happy to show you. Think you got 'em?
Oh, you don't get over. Move over, man.
Ready?
So I'm
About ready to invoke the mercy rule. All right. If these were hard, I would be worried because this is the easiest part of the test. Let's start with A. These are just order of operations style problems. So it's just a matter of trying to tell yourself what to do first each time. Okay, look at this thing right here. What part would you do first?
excited side.
You multiplication, there's also division that comes with it. You can do them both, to be honest, at the same time, because they're separated by lower level stuff. But if we follow directly according to the order of operations, we would do the one that comes first, from left to right. There's 15 minus 4 minus 10 divided by 2. So I'm only going to do one thing at a time. What should I do now? Now division is the one that is the highest order. About positive, you guys okay so far? We done? Then just subtract from left to right. What you get is you go 15 minus 4 is what? 11 minus 5 more is?
That's 6.
Any questions? That's division size. Okay, which should we handle first? Do the division first. In order to do that division, what do we do?
What the results?
Take the reciprocal and change it to multiplication. So far, so good. Now, if I can, I'll do some simplifying of those fractions that are multiplying to each other, but there's none, like that 7, I can't cancel anything with that 7, so I'm kind of stuck with it, so I'll just multiply those fractions, and I get 7/9 plus 7/18. Now what should I do? Who would work?
18.
18 will work. So to change that to an 18, I can change this to 14 over 18. I get my 14 over 18 plus 7 over 18. That's 21 over 18. Oh, good question. You guys didn't ask anything. My brain asked the question that you don't know what I'm talking about. You might ask yourself, do I have to simplify? The question did not specify that. Since it did not specify that you don't have to simplify, you don't have to. However, you should always be simplifying anyways, because you'll get asked it all the time. Anyways, can that be simplified?
Yes.
What goes into both of those numbers? 3, that's right. So if I divide the 21 into 3, I get a 7. Divide the 18 by 3, I get a 6, not a 3. And so our final answer is 7 over 6. Think somebody had fun with this one. All right. Once again, you should ask yourself, what should I be doing first? With the highest order of operation ever. Parentheses. I have lots of parentheses. They may not mean anything. Like these parentheses right here is just so because the negative is in there. They don't really count, if you will, as parentheses. Just like that doesn't really count as parentheses. They're just holding. But there are parentheses in here. Where are they and what should I do? And I should do them first, but where are the parentheses that I should do first?
Take the parentheses around the 2 minus the 2.
Right. So what I have. Those parentheses. So let me mix what's inside of there. Now focus your attention inside of those parentheses. Now, what part of it should I do first? You should do the exponent first. So you shouldn't even bother with 2 minus yet. That's there. But what about if you take -2 and you square it, what do you get? 4. +4. Right? I'm not done with these parentheses yet. Now what comes next? 2 minus 4 is gonna be -2, which is gonna put us in exactly the same kind of a situation as before. And then now exponent would be the most important thing. That's gonna be -2 squared is 4 again. Now I can do -5 times -4, that'll be +20. And you end up with 20 minus 4 is equal to 16. Okay. All right, let me go ahead and find B.
Three parentheses, 10 minus 5. C's times 4 by
But my already stuff.
what reason bracket.
Yeah.
And first 130.
All right. What part, tell me what computation should I do first?
Parentheses beside the brackets.
Where, what are we talking about?
That's 18 minus 5.
Do the 18 minus 15,
Yeah, from what?
so the rest of it will be left alone. That's just equal to 3. I didn't touch anything else. Like so. Inside the brackets, I should do the multiplication first. So I would get 23 plus 12 divided by 5. 23 plus 12 is equal to 35, so I get 35 divided by 5. And that's equal to 7. Okay. Hope I use them all the time. Let's go ahead and take a break there. Come back at 2 o'clock. We'll see if we can get through this test. Well, we've done enough word problems. So if we don't get to the word problems, it's not a big deal.
You still there?
They're one between, there's that one. I hope this one's easy. Give it a try. All right, you guys get -8? -8? No, -8? When you insert the -6 in for X, you should put it in parentheses. So that you remember to multiply and all the negatives and positives work together. So when I plug in -6, it's going to look like this. -6 squared plus 8 times -6 plus 4. Now, then first thing I'm going to do is the exponent, which is the square. That's positive 36. You should do the multiplication next. 8 times -6 is -48. Now I can just go from left to right. 36 plus -48 is -12. And -12 plus 4 is -8. Okay. Oh, no. What am I going to do about that? I'll rewrite it without slashes through it so that you can work it. Let me rewrite the expression there so you. Help with slashes or boundary. The only thing I have up there is the solutions. just simplify that expression. So that amount, what does that amount to in this problem? That's all it is in this problem is combining like terms. This one, it should be pretty quick. The reason I have my slices through them is because when I start moving stuff around, to prevent myself from losing track of things, I mark them off as I use them. So you can say I put the X squares together because that's where they belong. And then I'm gonna put the -8 to the back and put my X's together. Like that. Are we okay with what I just did, just moving stuff around? Now my X squareds, when I combine them, how much X squared do I get? 5X squared, right? -4 + 9 is 5. So these two right here, that gives me 5X squared. All right, what's the result of this part? -2X, this part right in here is the -2X, and -8 just does its own thing. And that's all there was to that one. Questions about that? Hopefully that one is an easy one.
Does it matter if it's in the wrong order?
Nope.
The same numbers?
As long as the numbers are there, it's fine.
All right,
So
thank you.
that -8, you could have written it with the -8 first if you wanted to.
Yeah, that's what I had done.
Yeah, it doesn't matter.
All right, thank you.
All right, here. We have another, it's a different style of word problem that we did not do today. I'll have to grab it. Thing here. Try not to grab any of the solution. Would you agree with that equation? Now read the problem and change the A and the S to things involving L. How is how do you say that guy's name? Ahmad? How do you say his, what is it, Ahmad? All right, so for his, how is it expressed in terms of L? That's right. It says that he has $6 more than Leah. Right here. This line says that A equals L plus 6. So I have my L for that. I have an L plus 6 for this. Can you tell me what I could write in place of the S? 3L. Because it says Scott has 3 times what Lena has. And here we have one unknown quantity, L, is telling us the value of all 3 of them. So as soon as I figure out L, I have all of them. Well, to solve this, it's just a matter of collecting your like terms. You get a 5L plus 6. And solve it in your normal ways, subtract 6. Get 5L equals 110, divide by 5. L equals 22. So then once you know that, you're ready to start getting all of these numbers. How much does Ahmad have? 20, because he has $6 more than Lena. Lena, of course, has 22. And how about Scott? $66 because he has 3 times what Lena has. How can you check yourself now that you've got the answer? Add them up, and you've got to add up to what? 116, they give us 50 plus 66 is 116. Remember that it's huge push on the earliest word problems where that we were using one, even the later ones, we were using one quantity to describe multiple things. Well, here's an easy little one, I hope. Teeny little one. This is actually a word problem, but if you remember the way we did these, I was able to write an equation directly underneath of this sentence. You remember that? Word for word, you can translate that sentence into mathematics. Anybody get it? 60? So if you write the equation directly underneath of it, change the percentage to a decimal. We did several of these. I don't remember how many we did, but 55%, what is that as a decimal? 0.55. What about the word of? No,
Times.
times, it's multiplication. What number is a word for X? What about is?
Equals.
And then the number can just come down. And then just, there's not much to do here except for divide by 0.55. You can use your calculator for this. I think you'll find that X equals 66 or 60, sorry. But those are pretty easy problems. I'm hoping, like, seriously, the sentence you can see just writes itself. Or the equation writes itself based on the sentence. What is that? Does that work? Oh, I see. Oh, I must have done double-sided. Okay, these things. Huge chunk, as you can see. It's almost half the test. Unfortunately, I have made some marks in it, but. Let me, just before I throw these at you, let's just, we can, oh, I cut off some, didn't I? What a bummer. We cut off there too? It was. Hold on, I'm coming back to it. I need to grab more down here. I'm afraid of grabbing into the stuff I wrote, but I might not be able to help it. Yeah, we got everything now. Instead of having you do all of them, because of time and what that, let's talk about the easy ones and then we'll do let you do the harder ones. So for example, let's start with this one right here. How would you solve this first equation? Just tell me the move you would make. All right, do you guys understand? You would subtract 5/8 from both sides of the equation. And that's all there is to that one. You'll have to get a common denominator. You can look at the solutions later. But the easy ones, I just want to whip through these so we can deal with the harder ones. What about this thing right here? What would you do? Divide by what? You can divide by 7/2. You could also multiply both sides by 2/7, which is the same thing. You'll see what I mean. Let me look at B then. The only thing that makes some of these hard is the fact that they have fractions in them. So we have 7 halves U. Now, you say to divide by 7 halves, so I'm going to divide by 7 halves. All right, that's good because this cancels all of this and that's the right thing to do. Now we have U equals 42 divided by 7 halves. Now, how do you handle it from here? I mean, that is the answer. That's a correct answer. Everything like that, but how do you simplify it? No, that's one thing you have to subtract them. This is where I was talking, when I was talking about doing, this is the same as 42 times 2/7. When you divide by a fraction, don't you turn it into a multiplication problem, but you flip the second fraction? So look, I had a division problem. I flipped the second fraction and turned it into a multiplication problem. I can save myself a little bit. I can actually do some simplifying here. 7 goes into that 42 6 times. So what's left over here? U equals what? 6 times 2 is what? How about C? That should be easy. What? Just tell me the steps that you'll do for that. You would not, so say again. Add 15 to both sides. So you get 60 equals 4W. Then what are you gonna do? Divide by 4, you should get W equals 15. I'll leave that one to you guys. D though, try that one. That's a little hectic looking. Anyway, think they got a solution? No solution. No solution? Let's see what happens. Let me grab that one. Instead of trying to trust my memory, I'm gonna grab it. And we'll work it down there. Okay, well, you can see the arrows kind of indicate you're gonna have to distribute those numbers through the parentheses. So with that said, I'm gonna have negative 2b minus 2. You agree with that? Okay, then I'm gonna leave the 5b, of course, is not doing anything right now. I'm gonna distribute this 3 through, so I get a 3b plus 3 minus 2. You get there? Now, I'm gonna do the first step of solving any equation is to completely simplify each side before you start doing anything. So all I have to do on each side is collect like terms. So I've got a 5b and a minus 2b. It looks like a 3b minus 2. And over here will be 3b plus 1. Then your next move is usually to try to get the letter on one side, so I would subtract 3b. Well, this is when it gets strange. So what I have here is negative 2 equals 1. Let's see if it's false. I use a series of logically correct steps and arrive at something is false. That means the initial assumption, the equation, must have been wrong. So all you can do when you get to this is no solution. Now there's a second thing too that's weird. What if at the end of this, like I had done all this, and instead, what if I had gotten this as my last line? What would that tell you instead? All real numbers. So when you get a false statement, that's no solution. When you get an obviously true statement where the x's have all disappeared, that means it's true no matter what value you actually put in. So that situation there, remember that this is all real numbers. Please make a note that this is not related to that. Some people just write down things and then when they go look at them later, they don't know. Most of it should be. Do it for this one. All right. I should run this feeling. Let's do E. Anybody think they got it? Negative 122.5 is what I got, or it could have been negative 245 over 2. That was another solution. What I would do, to be honest, is I would multiply everything by 7 at the very first step. Did you guys think to do that? You left that 7 around? Okay, you can do it. Maybe I made it harder than, what would you do first then? Subtracted 15.3 to both sides. Minus 15.3. Minus 15.3. My guess is if there was an issue with this problem, it would have been in this step here. That should be negative 17.5. Those two negative numbers, they combine to make a larger negative number. And to finish this off, what do? Multiply both sides by 7, so I'm going to have negative 17.5 times 7, that's going to equal x. And I am almost certain that that is the negative 122.5. So that wasn't enough fractionation to make you multiply through by the LCD. Maybe the next one will be. That was E. How many of these things are there? Yeah, go back here. No, that was from before. There. I want to do one like this to make sure we get through one with lots of fractions like that. Now for these, I advocated for multiplying through by the LCD. What is the LCD here? 12. How do you get 12? Because of the 3 and the 4, right? So if you imagine if I were going to combine all those fractions, I would need a 12 as a denominator. Multiply the whole equation by 12 and you'll wipe out every fraction. That's my advice. You do it whatever way you want, but that's my advice. Did anybody do what I did and multiply by 12, or did you all do your own thing? Did you multiply by 12, just wipe out the fractions? Notice it makes it a lot simpler. The equation where it is right now should be very simple. I get, for my answer, I get W equals 7 over 52. I'm skipping some steps because of time. You can always go into Blackboard and see what I did on all of the steps. Let me come back to the equations that we're working on here. I've covered every style of equation. We haven't done all of these though. Are there any of these equations you would like me to do yet? If there's any of them up there you don't like the looks of, tell me, and I don't mind doing it. If not, I'm going to move on to the next thing. There goes the mouse. If I can find it, there it is. It's going to move on to the next thing. If there is a next thing. Word problems. Hey, look at number 10. That should excite you. 2 trains. How much time will we have? I think that is the last of them. Probably with what time we have left, you can pick. I think this is an easier one than 9, so let's do 9. Now, you realize that your exam is going to be made up of problems that are directly from the homework, correct? You know that? These words, if you look, this exact sentence is in the homework. All that I'm doing is changing the numbers. So you really want to practice this weekend, you can go back to all the homework problems and you can do them again without penalty. And you can practice till your heart is content. But also because of time, I'm going to have to jump in on this one and not let you do it on your own, but you can help me with it. This is a mixture style of problem here. I mean, you've seen things like this before. Blends, anytime you see a blend in a store, they're taking something cheaper and mixing it with something more expensive to get something in between. All right, so we have, what is this, coffee? One coffee is $4.24 for an 11.5 ounce. And the other one is $9.98. Oh, this isn't a hard problem at all. Can you find the unit price of each one of these and tell me which one is the better deal? You know how to find the unit price. What do you do to do that? Right. You take the price and divide it by the weight. So for the first one, the 11.5 ounce package, we take our 424. Divided by 11.50 Z. Tell me what you get. Round to 2 decimal places as your book suggests.
30 cents a
Or
cent.
what is it?
30 cents a cent.
It comes out to 0.37.
Yes.
Now, if I put the units in here, let me do this. $0.37 per ounce. So that's the unit price. That is the unit price of the first one. You always know because it's like this, per ounce or per pound or whatever. We have our unit price. On the other hand, there was another size. The 27.8 pound cost $9.98 or 27.8 pounds. Ounces. Use your calculator and tell me what you get for this one.
36.
To 2 decimal places, it goes to 36. Which is the better deal?
the larger.
Larger one here because it's cheaper per ounce. This is what you find in like Costco and Sam's Club and all those, usually the bigger quantities are cheaper. But I don't think I have time for anything else, so unless you can see anything that you want me to hit before we walk out of here. I think we've hit every type of word problem. This is just a unit price problem, so that's not that big of a deal. If you don't have any questions, we can call it quits. If you have questions, but you don't want your classmates to look at you with anger, you can wait till they walk out of the room. I'll be here for a few minutes. So I can hear you. Almost identical. All I'm gonna do, well, I mean, some of the problems will be different because I'll grab them from the homework, but it'll be very similar to this. I'm just gonna change the numbers. Export. And you know where to find that, right? In Blackboard?